Sweet. All right. So today, this is a Flair kind of tutorial. It's not, I don't have a presentation, and it's not about like the theory that underlies Flair. Last year, I gave a introduction to the ensemble common filter, and you know, I won't go over kind of that today. The goal is to walk you through the user's guide. So that you can run Flair, and we'll kind of modify it together. And then you can sort of see, and I'll walk you through like kind of broadly what are the different options and configurations and things like that you could change. So to start, I'll go ahead and share my screen. We have a user's guide. And it's under, it's at the Smart Reservoir website and under User's Guide. And there's a bunch of different kind of chapters in here. And we're gonna start with setup. And in setup, there are 4 different ways that you can get set up. What I mean by setup is getting things in their various directories, getting data, getting the code. One, you can download and unzip the files from Dropbox. And this still requires you to have these requirements already on your computer, which is RStudio, and then these are packages. And you need a more recent version of tidyr because it uses a pivot function that is only in the most recent. That's a lot more intuitive than spread and gather. Then 1B is actually how to do it manually, which is necessary right now if you want to have real-time access to the data, because it involves pulling from GitHub. This way to approach actually involves working with the terminal, where you need to create directories on your computer, navigating to them, cloning the repository. So the R scripts and some examples are in the Flair Git repository. The data is spread across multiple branches within the SCC data repository. And I won't go over the hardcore details here. The gist is that the catwalk is one kind of directory of data on GitHub. The particular reservoir's NOAA forecast is another. Let's see. No, sorry. We have the Met Station, the catwalk, the weir. This is a repeat that is will get deleted, and then manual data. This is data that is like CTT data. The files governing the SSS, things like that. And then there's the archived metadata, which is a huge file that's, you kind of can go to EDI to download. You can't put it on GitHub. And within the kind of, once you download the Flair code, within it is this directory called example configuration files. And within that are the kind of the 3 files that you need to be able to launch a Flair run.
Really quick question, Quinn. What version of GLM is Flair currently running? And is that the one that you need the executable that Matt sent along to run on Windows?
Yes.
Okay.
But it's in, if you clone the Flair repository from GitHub, it has those executables in it.
Okay.
To work on Windows.
And just to note that the GLM version that we ran yesterday is not the updated version. So if you ran for the GLM 3R, you're going to have to get the new GLM executables.
I'm not really sure what was in the version that was yesterday, but the latest version, some of the things that it needs are there's some it looks for extra variables in the name list that allow you to restart the model GLM in its original configuration was designed to be started once and run for many years. And so its name list doesn't have the ability to capture the full starting point of a simulation. Like there's variables inside GLM, like average surface temperature over the past X number of days that is needed to make ice form. And that was, you couldn't specify that at the onset, even though it was a variable that it was tracking over the course of a simulation. Things like that. Also, WinTow fixed a time of day issue where you could only, even if you specified that you wanted GLM to start at 8 a.m., it would automatically start at midnight because it kind of ignored the time of day that you gave it. And that's in the latest versions of GLM. But honestly, the easiest way to do it is the Docker. It's hard to see everyone's, as we kind of talked about yesterday, it's really hard to do personalized, IT support in this sort of environment. But if there's anyone with any major issues, if anyone who really wants to run this who's stuck, I guess I want a sense of how many people are trying to run this live and how many people just want to follow along.
Live.
And do you have it going?
I have the I have the Docker thing all set up. Yeah, I'm using a Mac for today.
Okay.
How about everyone raises their hand if they're live?
Hold on, I'm trying to actually see everybody. Live meaning you have it live, or live you want it live?
I have it live.
I have it live on the container.
Okay, that's all I'm at. Yeah. All right. Does anyone? All right. I guess the question is, does anyone who wants it live not have it live? Alex Alex, does Alex have Home Edition on her PC?
No. So I got it to work yesterday, but now when I try and do it, is there like a way to restart it when you've already started it? Does that make sense?
I know I had that issue actually, Renato. Are you on a Mac or a PC?
I'm on a PC with the Education Edition, and I was able to get it working yesterday, but now I can't.
So if you've already started it, and Renato can, I'll put this in the chat window. Renato can edit this, or Vahid can edit what I'm gonna. Where's chat? Did chat disappear?
Thanks.
I had the same issue, Alex.
You should be able to do.
You need to actually just start it if it already is. Except that's not the one. I think.
Well, you can do this. I'm typing here.
Okay.
If you type these commands, it's just going to wipe it out and start from scratch. And then do the Docker run that's in the tutorial.
What did you post what to do?
Oh, I just went to Kalen. Sorry.
Docker kill Flair. Docker RM Flair.
Kill Flair.
That's actually it. Okay, great.
That's it. Yeah.
All right. Well, this is super positive. And so let's see.
If folks, because this is something that we're also trying to edit. So folks can capture these issues, for example, and Alex, that you can't restart and things like that. We can then implement it in the
user's guide.
In the user's guide. Yeah.
So there are three comments that were given, but I have no idea which one you want to do first out of the three. In what order should one do that?
The commands that I just typed on the chat is only if the container stopped and you want to restart it. If it's
I
running,
understand that, but you did send three commands. So which one goes first?
I sent just two, and those are.
Same thing?
Yeah.
You do them sequentially?
Yeah.
Okay.
Kill would start if the container is running. It will stop it and remove. Will remove it from. I forgot the. if you do these, it's a clean slate. You can start from.
But you have to do both of them. Was Francois' question? But,
yeah, you can do both of them
yeah.
in this order.
Yes.
Kill and then remove. And
yes. Okay.
It may be overkill. You may not need to kill, but overkill is fine.
All right. Are you on, Alex? Okay.
No, but that's okay. Keep going. We can come back.
Okay. So once you have it all set up, your kind of entry, the main thing you need to have is an initiate, basically a script. You can call it whatever you want. That is what you're going to source in R. And then this will call everything else. And so, the script basically starts out with dealing with packaging. But since they're already, oftentimes I put this thing at the top of code just because if you already have it, it won't reinstall it. And, it needs to load the libraries. All right, then you need a directory for where the data are located on your computer. And this, Renato already modified this, so it looks in the right place within the Docker container. You need the code location, like where the Flair code directory is, and you need the where you want to save your forecast. And if you were doing multiple different forecasts or different configurations, you would change this, and you would save a new script. And then execute location. Go on.
I have a question. So that all that is an initiate forecast example.r.
Yes.
Where is that file when I go to when you go to the file thing? I don't see where that is.
Is this what you see here? You see these files? So if you click on home down here at the bottom left in the RStudio, go all the way to home, you'll see Flair users guide files, and then Flair simulation, and then initiate forecasts within that. And you won't see these other files yet. You'll see, I think you'll see these files, but not the working directory and these 3 files. Okay.
So home, sorry, last thing. So home will automatically go to the container root or whatever.
Yes. Okay, so then to set up a simulation, you need a restart file to where to start the forecast. And if you give NA, then it will use the observations to restart, or use kind of ones that you've set up in a configuration file. You need to name your simulation. You need to tell it how many days you want the forecast horizon. It maxes out at 16. You can do fewer than 16, less than 16. Don't worry about spin up days. I think I need to just remove that. I forgot. You need to, what day do you want to start the forecast? Sorry, what day do you want to start your simulation? I'll get to what that means in a second. The time of day, and then what day you want to start forecasting. If this is not the same day, if the starting day is not the same day as the forecast start day, it's going to use observed historical meteorology and inflows to simulate the lake, and use the ensemble common filter to update the model, but it won't start forecasting with NOAA data. So if there's 10 days between here and here, or in this case 3 days, then you have 3 days using historical meteorology before handing over to NOAA's 16-day forecast. And so you could, if you only want to do data assimilation, then you would actually set this to be when you wanted to start data assimilation, this when you wanted to end, and then set number of forecast days to 0. And it'll be a pure historical analysis. There won't be any forecasting done. This is code that is automatic. You won't edit this. This just converts in the right formats. Then the script runs Flair, and you won't need to edit this. And then it runs the plotting code. which you won't need to edit anything after this. And I should actually move this up so everything you need to edit's up. This says that don't forecast with the oxygenation system. If that's false. If it's true, then you will be adding oxygen in your forecasts. And that only matters if you're doing GLM AED. Any questions? So if you want to hit source.
Sorry. So yes, you've been using this common ensemble, whatever what it is. I forgot what that is. I have no idea what this means again.
It's a method for combining. So this example that you're going to do has 441 different simultaneous predictions of the lake that slightly differ from each other for a day. And the ensemble common filter uses the data to filter down those 400 and some odd different kind of different trajectories that the model is simulating. So the filtering means that it pulls them in to be more consistent with the observations. All right, so I'm going to source it, and everyone can source it. Hit source up here, and it will start running the code. And you'll see a lot of stuff fly by. There's some pretty large data sets it's reading in. And so I've used read_R, which is in the tidyverse. It kind of speeds it up a little bit, I've noticed. And but subsequently, it also gives you the columns names. So you end up getting a lot of red sent at you. I'd like it to go away. But that level of detail is something to fix in the future. But right now it's reading in the meteorology. And if you're over here, actually go to your working directory. If you're in Home, Flair, User's Guide on the panel on the bottom right, if you go to working directory, you will see files being created. And the coolest file in here is this observations post QAQC long CSV. This is a CSV that has basically merged everything that this team has done ever at FCR into a single long file where column 1 is date, or the basic time step that it was collected. Column 2 is the depth that it was measured. Column 3 is the variable that was measured. Column 4 is the value, and column 5 is the method in case it was measured in different ways. So when it has that, then that is what Flair then, it can go in and it says, oh, you're modeling this depth of this variable, and you've chosen to use these two methods, so it takes the mean of the two methods. Or you could just choose one method. Like the methods would be the fact that the DOSON measures temperature at 5 meters depth, but so does the thermistor chain. What do you want to do with that? If you put both of those methods in there, then it will take the mean of those two methods.
Where do you edit that, Quinn?
Where do you edit? We'll get to how to reconfigure Flair. So right now it's, you see on my screen, a ton of files just appeared. That is creating a NOAA ensemble forecast, a NOAA basically forecast that every ensemble member is used. Like it cycles through these. Each ensemble member differs in its NOAA forecast. And so now you can see on my screen, and please interrupt if you're not following or but now it's starting to run. Oops. Sorry. And it's telling you that right now we're running from July 12th, 2018. We're going to run to July 15th, 2018 using historical observations. And then it's going to hand over and run a 16-day forecast.
And I had a question.
Yeah.
I had a question from yesterday, which is you create 21. There's 21 NOAA ensembles, and then you create 21 different ensembles
within one of those.
Within one of those, is there a reason that you picked like 21 again? Was that just for symmetry? Like, could you have done another number?
I could have done another number. It's all symmetry.
Okay,
So right now,
okay.
Yeah, right now what it does, it takes, NOAA provides 21 different equally likely trajectories of weather over the next 16 days. Within each of those, they're downscaled to the local site because when you download those are for a 1 degree by 1 degree resolution box that FCR sits in. We have the Met Station. Laura Puckett, former undergrad, who's now a PhD student out in Northern Arizona, developed a statistical relationship between that 1 degree resolution NOAA forecast, the first day of that forecast, the one that's most likely to be kind of most accurate, and what actually happened that day at the meteorology station. And she built that, basically the statistical relationship that converts that 1 degree to the local reservoir. That relationship is not perfect. And so there is noise in that relationship that is added. And so there's 21 samples from that noise that are added to each of the 21 ensemble members. So the answer to your question, Mary, is it's symmetry.
So does that mean you have 21 square values? Oh no,
yes. No, not square. 21 times 21.
Well, that's 21 square for me.
Yeah, that's 21 squared. You're right.
So
Now
hence you're 400 whatever.
Yeah, now we have a permanent record of my inability to do math. Yes. Okay, so it's running. Oh, so you can see here, we are tuning 4 parameters. We're tuning the sediment temperature and the hypolimnion, which is zone 1, epilimnion, which is zone 2, the shortwave factor, and the inflow factor. So it's multiplying the inflow velocity right now by a mean across ensembles. Each ensemble has different parameter values of 0.5. It's multiplying incoming solar radiation by 0.7, and it's got about 15 degrees for the 2 sediment temperatures.
Is the inflow factor internal to GLM,
Yes.
or is that something? Okay.
It's a parameter that's in a name list. Okay. So in the working directory, the magic is right here. You see how this number is changing right here repeatedly? It's creating a new GLM name list for every ensemble member during every time step. And that's how it's changing the parameter values, initial conditions, everything. The reason why over here, there's this concept of an execute location. You can put this working directory on what we call a RAM disk, which is where it's using your RAM rather than your hard disk to write these files, and it saves read writes. For the purposes of this, actually, I don't know. I think that Docker actually runs probably in RAM. I have no idea, but anyway, if you're running Flair a lot and you're writing to your hard disk, I don't know for sure, but there is it'll run it will likely run slower, and your hard disk is limited by the number of read writes it can do over its lifetime, and you might as well just not wear and tear that. So that's why you can separate it, but for these purposes, you don't need to. It's not necessary. They're set to the same thing. So this working directory is doing a lot of read writes, and so it's basically updating GLM name list repeatedly with the new date, it points it to a different MET file, different set of initial conditions, that kind of thing. So it's running.
And Quinn, the inflow, file 1, file 2, outflow, CSV, these are also being generated for each simulation?
Yes. Actually, right now, this is something I need to fix. It's copying each one of them into the same file name. So yeah, it works fine. It's weird. I couldn't figure out how to get GLM, the name list, to put quotes around 2 things next to each other. So instead I just copy a file, so I don't have to change the file name in the name list. I
Gotcha.
copy the file to the name it's looking for.
Gotcha.
Okay. Let's see. So, like a baking show. You don't know how long it took to bake. So I'll go ahead and show you as yours is baking in your oven. It produces a netcdf file, which is the output, and it produces a PDF that's an example of plotting. But you can always go to the netcdf. And netcdf is a type of file that allows you to store things of all different dimensions, and is a very efficient way to store. And it's actually, as the Ecological Forecasting Initiative, right there, is developing standards for archiving forecasts, our priority is towards netcdf formats. All right. But it'll produce a PDF. And what's cool about the Docker is that actually, if you click on that, it'll when you see one appear on your computer, will produce a it opens it up actually in a tab in your browser. So this example of the kind of the diagnostic output that Flair produces. This is the if you're running a forecast that's a genuine forecast, you're not going to see any red dots to the right of this line. This line is where it hands over from the past to the future. You can see that we had uncertainty in our starting point. The ensemble common filter filtered down the ensembles very strongly because we have a lot of confidence in our measurements of temperature at the reservoir. It doesn't filter down these as strongly at these intermediate depths. And I can get to the reason why. It's because there's no covariance in the error structure right now in the model. That develops as you run Flair for a longer period of time. But the depths at which we have observations, it filters down quite tightly. Then it hands over to the forecast, and you can see this is the forecast uncertainty growing over the course of the 16 days. And this shows you what the forecast, the observations that eventually were collected were for that forecast period. So it has a bunch, it gives you all the depths that we simulated. And it's not doing as well at the deep sediments because it hasn't calibrated the sediment temperature. And then here's the calibration of the parameters. So you can see that we started the parameters with, we don't know what they are. So we started them anywhere between 10 and 20 for both depths. This is the hypolimnetic epilimnetic temperature. We started inflow factor anywhere between 0.5 and 1.5. We started inflow factor anywhere between 1 and 0. And you can see that it is strongly sensitive to shortwave factor, and it quickly filtered down and said that the ensemble members that had 1.5 were just garbage. And it filters down that to where we can nail down, approach like a more constrained value for shortwave factor. It takes longer to filter down the sediment zone temperatures. An inflow factor actually, it's not sensitive to the inflow factor really until you actually start to approach turnover in some cases. Have folks finished running? This is a test of your computer speed.
Yeah, but I don't have any PDF file being produced myself. I only have the NC.
Okay. Do other folks have that issue, or do other folks have the PDF produced?
Did you source it, Francois, or did you just run the out?
I ran the out. Oh, you're right. I didn't do the PDF, the plot forecast.
Yeah.
Right. Thanks.
Cool.
Yeah, mine just finished. Yep.
You're going to get some error messages. Like some of this is thanks to Wentao, who did a very thorough job with his QC script. So it actually tells you issues that you don't need to worry about, but you at least know they're there. I need to fix something with some sort of function that Tidyverse has, but it's not an issue. And then, and then the second one is a repeat because it doesn't assume you've already that you already have, creating the plot doesn't assume that you've already read in the data and created the QA/QC files already. So it redoes it effectively. So congratulations, you ran your first Flair. Yeah? No little clappies? Thank you. And so yeah, you've run it.
So what's so complicated about it?
Huh?
Nothing, I said. So what's so complicated about it?
Francois, all right, I will tell you.
Just kidding.
Your comment is so funny that I can hear Kaylin laughing over the monitor that's in Calvin's room, that's down in the basement, so that I can. So that's how hilarious your comment is. All right, so we're returning back to the script that the tutorial. All right, so you already had these 3 files. Initiate forecast was already set up for you, and I talked to you about how you could modify it. One key thing here is that this start time local is the local time zone of your lake, but you have to be very careful that when you convert it to Greenwich Mean Time or UTC, that it converts to one of these 4 options. Otherwise, it can't hand off to the NOAA forecast, and it will die. I actually put an error message in there. Of the few error catches that are currently in this version of Flair, this is one of them. You have since we're running GLM only, there's an already prepared nameless for you called GLM3 without AED. And then there's a configure Flair.r, and that we're going to get into that later. All right, you ran your first simulation by sourcing, which is shown here in the user's guide. You saw this show up, which meant good job. And it produced your netCDF and your PDF. So the tutorial then goes through on how you can examine your own output. And I don't expect you to do this here, but you could, because this sort of teaches you a little bit about how to use netCDF in R. So this assumes you've already loaded the netCDF4 library. I should probably add that into here to do that. And so this is what a netCDF output looks like. And so the file is binary, so you can't actually look at this, but you can look at, if you open the netCDF file in R and then print out the object that you're opened into, it will give you and allow you to look at the variables. So for example, temp has dimension of time, ensemble, member, and depth. It already pre-calculates the mean. Notice how this is missing the ensemble. That's because this is the mean across ensembles for each time and each depth. It already calculates the upper 95% and lower 95%. I need to improve this. One of the powers of netCDF is that it travels along with its own metadata. So long name is temperature. It's got the units. Mean, and here I need to put actually that's the 95% to be more complete, but it does allow you to travel along with the metadata describing each variable.
What's the field value at 10 to the 32nd or something?
That's an NA. It will store an NA as this value, but when it reads it in, it knows that that's a missing value. Some of this stuff you don't need to worry about because it's all about the ensemble common filter. And we'll get into some of this later down here. So anyway, and then the dimensions are time, ensemble, depth, and then some others that you need to deal with the ensemble common filter. Don't worry about that. And what's nice too is at time, it has a dimension, and then it will, it's the number of seconds, just because it has to be relative to something. But it, so that you can use the time dimension in your analysis. And it's got some global attributes that get automatically generated. Like this was run on the 30th of April. So you know the time that it was run. So this is how you know that this was not a true forecast, because it's forecasting 2018 in 2020. Cool. All right, so you can plot the Flair output. This just shows you how to get a variable off of a netcdf file. Here's temperature mean, here's the time. This converts time from the craziness that's on the file to something you can actually work with that has a time date format in R, your depths. This grabs you say, I want to plot the first depth in meters. This finds the depth index that's as close to that as possible. This is a tidyversy thing where it creates basically a data frame where one column is time and the second column is the temperature mean at that depth over time, and a ggplot, and boom, you plotted it. This is important because not everything was a forecast. Even if this was a real forecast, we have 4 days of data assimilation before the forecast. And so there's a variable called forecasted. 0 means that it was in the past. 1 means that it was in the future. And this just grabs that and colors the points, or colors the forecast, whether it was in the future or in the past. This isn't a tutorial in tidyverse and ggplot, but I give examples on how to add the uncertainty. I give examples on how to pull in the observations, which are the obs. And in the case of data in the past, you will have obs. In the future, you may not. Since this was a forecast run in the future past, then there are observations. And this just shows you how to actually calculate the confidence intervals for yourself. You'll need to do this for if you want different intervals than the 95%, and you also will need to do this if you're doing any water quality variables, because they don't automatically have the confidence intervals saved in the netcdf file.
I find the 95% confidence interval for water quality to be very, very harsh on ourselves. When we do ourselves uncertainty of the load calculations, whatever, we've decided to settle down to 90%, because these these 5 percentage points extra really make you look like it's terrible very quickly.
Cool. All right, how are folks doing? Rolling along? Good.
It's not going fast enough. I think you should speed up a little bit.
I will take that as sarcasm. This is exactly what Zoom is working for this. But this is why Zoom can't work for everything, because I know Francois well enough to know sarcasm. And that's because I've hung out with Francois in person. If I've never met Francois, I think I would have interpreted that as not sarcasm. So let's, we're not gonna run GLM-AED today. We're gonna move on to some other configurations. But I'll just walk you through here how to, if you want to set up GLM-AED. So for one thing, there are 2 options for, so the key, the name list file for GLM has to change in a few ways. And instead of telling you how to change it manually, I've provided you additional examples. With SSS, you can imagine what that is. That's with the oxygenation system on, because that needs to add an extra inflow and outflow, and without. So then you need an extra, you need the GLM2 AED, and there's 2 versions here. There's one that only has the oxygen module, basically, and one with a full-on AED. Then all right, this is a good chance to go to Mary's question about how do you start to configure things. And let's just skip this for now and go to modifying Flair, because we'll come back to some of those things you just saw. So how do you modify Flair other than the time of day it's basically forecasting and how much you want to forecast? Is you go over here to your Flair simulation folder and open up configure_flair.r. And under this are a bunch of configurations. And you're gonna look at this and say, hey, this documentation is not that good. You may emphasize different aspects of documentation, the U in documentation. You may want more. Well, it's here. The entire end of the user's guide is a description of every single variable that's in that file. Appendix is the everything that's in that file. So we'll go back here, the reason why I picked this up is right here. Include _WQ is include water quality. It's false. You would set that to true. There's a lot of stuff in here. So let's go back to the user's guide and what would someone like to change? Are there any votes?
I'm wondering if maybe before jumping into the variables, we can just see if anyone has any questions. How many people are still following? Okay.
Either Robert's frozen or is not following. It's communicating with a head nod. Okay. Let's see. What would be fun to modify?
So is that going to be like that an exam entry to go into the Carey's lab? You have to run Flair and show how you do it.
There are worse gauntlets to have to run through, but
let's see. Let's change the uncertainty mode. So there's ways to turn off different aspects of uncertainty. Let's turn off. Let's see. How about let's turn off all sources of uncertainty? Let's see if that breaks it. So you would go into here and you would go, and then you would change your source of uncertainty. We're going to change it to, let's see. So no source of uncertainty and no state updating with, and all you do is change that to 11. You would come into here and you would change this to test no DA, and you would source that. And that would run. So that basically that's as easy as it takes to change something in Flair. And so I'll walk you through kind of things that you can do. One, you can, while that's running, you can add different parameters or take away parameters. And the parameter names need to match the parameter names that are in the GLM name list. And you do this basically, let's see, right here. In the Flair figure, there's par names save. The reason why that's different is you may want to have a different name in the file that you save. Sediment temperature mean, actually, it puts two values for the same variable in the name list because it's zone 1 comma zone 2, but in your file that you want to save, you need to tell them apart. So that's why the name save is different than the actual par name. You need to give it the NML where it can find that particular parameter. The mean value that you want it to start, the mean value that you think it should have, its upper and lower bounds on initiation. That was that like 10 to 20 degrees that I showed you. The lower bound, basically an upper and lower possible for it. Right now, these are set to be really large, so it doesn't really control. But like inflow factor can't go negative, so it's got a negative, like, or a 0 lower bound. Don't worry about this, and then the units of that. And so you need to have values for that. And I've already given an example of where you might do it for all these different parameters here. And the user's guide shows you if you want to zero out and not do any parameter optimization, you would actually take par names and have it equal to an empty vector.
Quinn, I might have missed this, but when you're setting those, is it just making a uniform distribution in between those upper and lower?
Yeah, it's a uniform for now. So that's an example. You can increase observational uncertainty. That's a test that we could do. And you'll see that it doesn't pull it in as tightly during the ensemble updating. And there's two components of observational uncertainty. There's what we call the slope and the intercept. The intercept is independent of the measurement or the prediction. It's independent of the measurement, and the slope is linearly dependent on the measurement. So if you think that as a number gets smaller, as like a measurement gets smaller, that it has more certainty in the measurement, then you would actually have a non-zero slope. But if you're just saying that the uncertainty on DO is has a standard deviation of blank, then that's and it's actually a variance, and I specify that in the has a variance of blank. Then you would only give an intercept.
So for like chemistry data where the lower values are less certain, that would be a negative number, that slope, because as they get smaller, as the values themselves get smaller, the observation error gets larger. Is that?
Does it?
Well, like our certainty, like we don't have, if we're below like our MDL or our limit of quantitation, like we don't have as much information there in the value.
Yes, that would be negative.
Okay.
Or, if one wanted to change Flair, one could provide another term that was like a threshold and an uncertainty value if you are above and below threshold. You can play around with this.
Oh, that's cool.
And you would need to, that'd be very like expert to do, but you can change it so that it has different uncertainty at different values. You would just need to write the code to do that.
And how did you build, so the intercept you've gotten from like the sensor calibration issues or like from the manufacturer, but like how did you build in the slopes?
I don't have any slopes.
Okay, so it's all set to 1.
Well, they're all set to 0.
Or 0, yeah.
Yeah. But I have that possibility. It's a little bit tricky. Like anyway, it's just, there's a flexibility in there you could use, but I don't use it.
That's really cool though. That's like a super cool thing.
Most people don't use it. Like that, we didn't read any papers that describe this sort of level of flexibility in the observational model in its uncertainty. You can change the ensemble size. You can change the number of the depths that are simulated and what values they are. And then we'll skip over this for now.
I think Quinn, just going back up for 7 for Ty,
Yeah.
who's interested in.
Oh, we'll come back to that.
Okay.
I'll come back to that. I was just saying that there's a bunch of other things that you could. I'll just briefly go through some of the features. Null. You can do a null model where it's a persistence null, but it calculates the process uncertainty on the persistence null, so it doesn't even run GLM. It runs really fast. If you just want to run it to run GLM, you can use a single run. It doesn't really work with just one ensemble member, so it basically zeroes everything out for you, and you only have 3 ensemble members, but they're actually exactly the same. But if you just want to like run GLM over a period of time using the Flair framework, that's what single run is. Pushing and pulling from Git is how you pull from Git if you want to access real-time data. You push to Git if you want to archive your forecast. Lake variables. There's some weather forecasting options. Basically, do you want to downscale the Met data? If you want to do a run where you're doing 16-day forecast but using observed meteorology, you would toggle use future Met. Controls over inflow, the inflows. Whether you want to use forecasted inflows or observed inflows. Some of the if you're using forecasts or you need to parameterize a very simple first order autoregressive model, so you have to provide that. The name of your name lists that need to be in your simulation directory so that it knows what to look for. I already called them GLM3_ without AED, but you could change that. And if you change that, it has to be changed in your configuration file. Your model depths, your ensemble size, how many ensemble members you want to have, how many downscaling members you want to have, and how many basically inflow outflow members you want to have, and that's adding noise to the inflow and outflow.
Quinn, stepping back up.
Yeah, go on.
Stepping back up to the null model, does that mean you could use a deterministic run of GLM as the null model?
It wouldn't show up as null.
Okay.
You would use single run.
Okay, gotcha.
Let's see, name list. Process uncertainty adaptation. It basically calculates the predictions for the next day, compares them to the model, the predictions to the observations, figures out the residuals, uses that to kind of develop an idea what the predicted noise is in the model, and it does that using a 30-day running mean. And you can use covariance as like, do you want covariance in your state variables, or you just want to have one variance for each depth, and it doesn't depend on uncertainty in other depths. So for example, if that's false, then each depth gets its own process variance, or basically white noise term that's added every day. But if you want depth 1, the first meter 1 to depend on meter 2, so that when one's randomly high, the other's randomly high, then you would use covariance. Do you want it to adapt or not? Basically, do you want it to calculate it from the running means? Number of days you want it to calculate the kind of the running mean residual that's used to develop the error term. And then this parameter to basically prevent the parameters from collapsing onto a single value. Basically information on calibrating the parameters I already went over. A lot of observation information that I won't get into the details are, but it's basically where the files are. You can have 2 files. One is a real-time file. That always has to be first. And then if you already have a QA/QC file, and that's second in your file name list. Some stuff on converting like the CTD to the XO. This one here is cool. You can have the option if your thermistor is attached to a buoy, it has constant depths. If it's attached to a like a catwalk and there's a high variation in the water levels, then it will take your file and convert the depths in your observations to the actual depths that are kind of being simulated. So it allows for your data to have variable depths through time.
This is part of the motivation for getting the new pressure transducer at FCR.
See, here's where the methods are. Like for example, temperature method, we actually have 4 different methods for measuring temperature at the reservoir. And so you specify the ones that you want to include.
So this would be where you choose like which versions of data you're assimilating.
Yes.
And then do they already have different observation error models, for example, like automatically?
No, they all have the same one right now.
Okay.
Yeah.
Just curious.
Yeah. These are all things that could be built out. Right now, if you put like all 4 of them in there, it'll take the mean. It does it for all, the nutrient chemistry as well, FDOM. And the grab samples are the ones from the nutrient chemistry, EXO, that kind of thing. This is cool. Time threshold for temp. What range are you willing to accept? Like, if you're modeling, because this goes from like 7 a.m. to 7 a.m. And do you want to grab just 7 a.m. or are you willing to accept 6:30 to 7:30? That kind of thing. And that might differ by variable. You maybe say temperature, I need it. I don't think that, but maybe chlorophyll, you're willing to accept the average over a course of a day. So that kind of does that. What's the distance? Are you willing to accept a measurement within 0.2 meters as applying to a particular depth? That kind of thing. Initial conditions, don't really worry about that. A lot of water quality stuff that I won't get in here, but this is for setting up GLM AED. The observational uncertainty that I already went over. The process uncertainty for the various states. This is kind of what you think your initial variances are for the kind of the model's inability to predict that particular variable. Initial condition uncertainty that you right when you started the model run. A lot of stuff related to the SSS, whether you want to simulate it or not, whether you want to include it in the forecast, whether you want to use the file that you're providing on how much oxygen is coming in and at what rate, or do you whether want to be a specified value that's just in the configuration file, the depth that it's coming in, and then some plotting related features that basically, what are the 2 depths you want to consider comparing for a turnover? So while that ran,
cool.
so while that ran, my node data assimilation one finished, and you can see here, we started it here and it ran, and compare that. Oops. Look how assimilating data improved our forecast. So 1, the model was initially biased high, and that just continues along when we transition to the forecast. So this example of no data assimilation here, and this example of with data assimilation. So a lot more initial condition uncertainty that then results in more uncertainty 16 days out. But not that much more, because the uncertainty 16 days out are, is driven a lot by the meteorology. You go down to the parameter values. Look at this, SW factor starts to already get optimized or calibrated within the first even just few days of running the model. Look at this, it doesn't update at all because there's no data updated. So it just carries through your initial uniform distribution. I think we might have time for one more. What does someone else want me to play with? Configuration.
I was trying to see where you actually configured no data assimilations, because I went 11 on the all sorts of uncertainties and no state
Yes.
updating. But I have a data assimilation myself. I mean, clearly on my results. I don't.
Did you change uncertainty mode to 11?
Yes.
And you still got that?
Yes. Somehow.
Oh, okay.
What else? What else did you change?
I resourced it. Did you resource it? Because
I'm not sure what resource mean. I retyped source. I clicked on source again. I'm not sure what resource mean.
Well, yeah. Did you source it again? If you didn't do it, it won't reload your configure Flair file and it won't bring in the new configurations.
Okay, I don't know. I must have done something weird, but I thought I did save configure Flair.
Let me start something else and maybe we can work through that. Of course, yeah. Mary seems to really like to think about the data uncertainty. So let's go back to all sources of uncertainty with data assimilation. But then let's go to temperature uncertainty. So this is, I square it. So this says that the uncertainty in temperature has a standard deviation of 0.1. There's no slope, but then this is squared because it needs to be in variance. And the reason why it needs to be in variance is because we work with variance covariance matrices in a multivariate normal distribution. And so things have to be in variance and covariance terms. So Mary, what do you want me to put? What do you think?
For temperature?
Well, we're only modeling temperature, so.
Right. I don't know. Let's jack it up. Let's do 0.5, half a degree. Really bad temperature sensors.
I think they're horrible. I'm gonna put it 1.
1, okay.
I actually think they're really bad. I'm gonna put it at 2. I think Mary drops hobo loggers in the reservoir.
Nope, just fluoroprobe parts.
All right, so then we would come back here. I would change this to Mary's observation uncertainty. And you get a gold star for finding anywhere in the code I misspell uncertainty. And we're going to resource it.
Instead of gold star, just Bitcoin.
Isn't Bitcoin worth negative now?
I don't think so.
Doesn't it track the oil? Cool. All right. While this is running, ask away.
I'm wondering, Quinn, if you might go up to section 7 in the guide.
Yes. Thanks for bringing me back.
Because I think there's a lot of people in this group who are interested in Flair for their lakes.
All right. Perfect. All right. So Flair is is dialed into FCR. So I've tried to talk about how I would do this to a new lake. This hasn't been done directly in the version that is currently here, but hopefully this kind of gives a possible guide. So there's you'll need to modify your name list. Key things are, big things are, you've got to put the morphology of your lake. So you need to change its hypsomographic curve. Is that right? Is that the right pronunciation?
Hypsographic.
Hypsographic. Your inflow outflows, things that you just need to do to set up your model for a new lake in general. You'll also need to modify the zone heights because your average depth epilimnin. You can tell I'm not a limnologist. The top and bottom have different points that different depths, so you'll need to do that, and you probably have a different KW. You could optimize KW if you wanted to, which could be cool. I haven't tested that, but that could be available. Remember that there's going to be a lot of trade-offs So if you're trying to do shortwave factor and KW factor, they kind of control similar things, which is light penetration. So you got to be careful whether you have enough data to constrain two things. So you just can't let all parameters loose. All right, within configure Flair, you need to change your lake name, and it needs to be a four-letter code. Change the location, the time zone, the initial depth of the lakes, and the model depths you want to do. Oh, the initial depth, like, you know, 3 point, you could put, you know, if it's a 50-meter deep lake, you need to put that there. You know, link, you know, you'll need to, you know, basically like set up your data directory. Let's see, then, you know, your methods. All right, the big kicker here is within Flair, this is the example of the structure of the Flair directory. So there's example configuration files. The GLM is where the executables hang out. You don't need to change that. R scripts, the way the R scripts directory is structured, in theory, anything that sits right within this works across lakes. Anything that's dialed into FCR is within this FCRE. I know FCR people are annoyed by that E. That E is there so that we can easily interface with neon sites that use a four-digit or a four-letter code. These are the things that basically are dialed into the data format of FCR. And you'll need to go in and modify these for your particular data format. You need to modify these scripts in a way that outputs the format that the scripts are expecting to output, so these other scripts can interface. But other than that, like, it should work with a new lake. And so we're working to containerize the containering that that was covered earlier. We're working to, like, basically all this stuff would be in its own container, where that gets called, and then all this other stuff is in a separate container, so that, like, you basically have to modify one container for your lake, and then it's done. But then it can call, like, the ensemble common filter based container that's basically all this other stuff. So yeah, like the Met QAQC reads in the two meteorology files, and it outputs a clean Met file, and it needs these, but then it's going to write these. You know, and you may not have to modify that. It depends on what the format is of your file, the Met file that comes off your meteorology station. Inflow QAQC, you know, the in situ QAQC file. You know, it needs to output timestamp, depth, variable, and method. And then extract CTD, reads it in. These all are under QAQC. The reason why this is indexed here is because this is the master script that calls the catwalk, CTD, nutrients files, so that it pulls that all together. Does that help? So once this is dialed in for a neon site, then you would use a different code number here, but it might actually be the same code repeated for every neon site. Because it's standardized across sites. The format. You may not have to modify these files if your data format is the exact same as FCR. But it's going to be looking for the four-digit code for your lake. And this is the same four-digit code that matches your repository where you're saving your NOAA forecasts that you're downloading as well. It's not a digit. I guess it's a character, four-character code. Other questions? Was that a brief introduction to how to modify it for your own lake?
Question, Quinn, for neon lakes, how much, I think one property or one goal of neon is to have homogeneous data formats and the same kind of measurements done at every site. Now, once we cover one lake, what's going to be needed to cover additional lakes in neon? Is that mostly going to be on the GLM side?
Yeah, each lake will have to have its own like hypsographic curve. So we'll need each lake to have its own basically NML.
Right.
Which ideally what we would do is move to a case where it was specified in a configuration file and then it entirely wrote the NML from that. And so everything would start from the base NML. We can move more and more stuff into the configuration file and less out of the NML file to make it even more kind of flexible.
Gotcha.
And then, so with that, but the reading in the data, those files I just showed you here, that are in this directory that's in the rscript sub lake name. If we wanted to, we could call that just neon. And it would apply to all neon sites, but there would need to be a way to make sure. Then we would need a second code for accessing the right NOAA download.
Right. And what's the how many neon sites have lakes?
Kayla?
There's eight.
Eight.
Yeah.
Gotcha.
Though it's not all of them are completely online, so we might only be doing 6.
But once they do get online, is it? I've seen a neon tower, but the lake sensors will be pretty much also the same across, consistent across all lakes.
Yep, and you can look over Quinn's shoulder so you can see what they look like. That's what the standard lake deployment is.
Oh.
Can you see me? I'll talk to it. There you go. That's what a lake deployment looks like.
Gotcha.
Yeah. Keep asking questions.
Out of curiosity, how different is this from when Tig got this working for Laufia last year? Maybe Tig can answer that too. I don't know.
How different is the Flair setup, or how different it is to set it up for my lake?
How different is the changes you had to make to, well, yeah, maybe both, but for you to get it set up for Laufia, how different is this process now from what you had to do that?
This is probably quite a newer version. I'm working off a slightly older version, but most of it's still there. And because of the modularization, like Quinn said, of having that folder, where basically you can just write your own scripts to take your own data and put it into the Flair format. That was hugely helpful for basically getting things into the right format. And basically, I just tried to copy most of what was already there rather than rewriting a bunch of new scripts. But yeah, and it was easy enough to kind of, well, okay, it wasn't easy enough, but it was a learning process, which was good because I kind of had to step through a lot of the code, which now I understand most of it. Well, most of what was written with the version that I'm using, but yeah, overall I thought it was relatively straightforward.
This user's guide, Quinn, is a huge contribution, I think. And so a big shout out to many people that made it possible. And Abby gave a lot of helpful feedback. I think Ryan tested this. And many others kind of behind the scenes but Quinn was really the lead on pulling this together. And I think in terms of scaling to neon sites and to FIA and many other Gleon lakes, I think this is huge. So
Quick question, if it's not too late, sounds like, are you wrapping up, Kaylin, or no?
shortly, we're going to be transitioning to the SCC meeting at 11, but go ahead, Paul.
Okay, so maybe for both you guys, Quinn and Renato, do you see any time in the sort of near future a totally server-side version of this?
So I can start with, the idea is, we're beginning to tease apart things that, within the Flair code make sense to run as separate modules. So Vahid has implemented the NOAA download, and he's working on QAQC now. So we're knocking down individual containers now. I think, the server side is, I'd like to have something at the end of this summer, something that's a version 1 of that, taking Flair as it is now and making it broken into containers. And I think one aspect that we should keep in mind is, there's a server side orchestration that's going to have, so we have a system that runs under the hood that's called OpenWhisk, that's going to be responsible for triggering, orchestrating sort of the workflow of the containers. But I think the way we're building it, it should be possible for somebody to also do manual orchestration, right? To run a container, then run the next container, and do that to sort of work through the kinks of the system before deploying in an automated fashion.
Yeah. Cool.
Quinn, I don't know if you wanted to go back to the Mary's container observation uncertainty, or is it still running?
It's going to come in. It just wrote the netcdf file, and now it's writing the PDF. And so there we go. All right, you ready, Mary? So, whoops. All right, there you go. That's the role of, you can see, so that you see how it tucked in really nicely here? And when you put 2 degrees of uncertainty versus, whoops, oh, we actually have 3 scenarios here. All right, you ready? Let's see if I can move this. All right. Data assimilation with high observational uncertainty, or high certainty in your observations. Low uncertainty in your observations, and no observations. All right. High certainty, or low uncertainty, high uncertainty, no data. So there's still information and a temperature measurement of with 2 degrees of variance. No, the standard deviation of 2. So that's, the variance is 4 degrees.
It still pulls it in. I mean, like, it pulls it in less, but it definitely pulls it in. That's cool.
Yeah. And so the big question too is what, like, all right, so here is the shortwave factor. So you can see that the parameter got, 0.8 to 0.6 was able to pull down within a day or a few days of data assimilation. Compare that to, like this, about 0.1 to 0.6. So it's not constraining the like the parameters as well, versus this that, I mean, it's just our initial guess.
One very quick note to interrupt, sorry, Quinn, is that we have a special guest joining us from Wisconsin. Wen Tao is here, who helped write some of the code and did some of the error checking, which enabled the tutorial. So it's great that he's able to join us remotely. So thanks, Wen Tao.
No, too late. It's good to see your faces, old and new.
Cool. So should this wrap up?
Yeah, this is great. Thanks so much, Quinn. I'm
Yeah.
going to stop recording unless there's any other questions that folks have before we wrap
Does
up.
anyone have any questions, comments? Cool. If you have any